To solve a recursion problem in Sage, we are going to start by creating a new Python notebook. So we write here whatever name we want for our recursion, let's say create. And so here we're going to say that it should be a Sage notebook. Okay, so we have here already the cells where we can write the code as we would do in the Sage notebook. We can also write text if we like, so we may want to write what we are going to do. So let me write down here the text and run it. So here I'm saying that we are going to find the closed form for this homogeneous equation with initial conditions s0 equal 2 and s1 equal 7. Okay, so in order to do that, we are going to start by telling Sage to use SymPy. This will be always the same, just copy that code like it is, we run it, and then we start declaring what we need. So we need a function for this s here, so I declare that this letter s will be function s run, and then I'm going to write down what the equation is. So I'm going to write down this equation, right? So I'm going to put that the equation is Sn minus Sn minus 1 minus 2 times Sn minus 2. And so I run it, and this is the equation that we have it in here. Okay, so we can ask Sage to solve it now. And so we put solve. In sol is going to be the solution, and so I run it, and here is the solution. See, the solution is in terms of the constants, right? Because we didn't give the initial conditions yet. So let's give the initial conditions now. So for the initial conditions, we have that s0 is equal to 2 and s1 equal to 7, and these are going to be the initial conditions. Run it. So these are the correct ones. And so now we are going to actually ask Sage to give us the closed form. So we write close, for instance, for the closed form, and we are going to write our solve, the equation, I mean the one that we wrote here, Sn and the initial conditions that we give here. And so we run it, and this is the solution of our problem. So this is then the closed form corresponding to the homogeneous equation.